Okay, this video is going to be on drawing exercise 7.2, the rod support. 7.2 in the 15th edition. And it is a metric drawing. So we want to start with a metric standard millimeter IPT template. And but just because of the shape of this one, I want to draw it on the front plane. So I want to draw on the XY plane. That's rotated good. And what we're going to do is I'm going to draw the profile of this thing, and then I will constrain it as we go and as we finished. So I want to come up 13, horizontal to the right. I'm pretty sure that's going to be 25. Pretty sure it's symmetrical. And then vertical, 64 minus 13, 61, 51. Yeah, that's right. Okay. And then across 19. Down, I don't know. Oop, perpendicular, okay. Across 25. And back up, even with that one. Over 19. Down even with that. Over 25. Down even with that. This is boring, isn't it, watching me draw? And that comes up 17. You notice I didn't put in some of the dimensions, but we will come back and finish those up here. Okay. So based on what we've got here, I have an overall length of 113. Oh, okay, so that's already there, so we will accept it. And that should be 39. Okay. Let's see, 13 high. I want to, I'm going to go ahead and get this thing constrained, and then I'll finish my dimensions when I stop the movie. What I want, I'm going to project geometry and bring my major axes in. And I want to put the center of this on my y-axis. So I'm going to go coincident constraint, midpoint to the axes. Then I'm going to go collinear to get the bottom of the object on that axis. All right. Oh, I only have one dimension left, and I know that it's from here to here. And that was 13. And we're fully constrained, so I can extrude. I'll finish the sketch. Now with this one, pick my profiles there, and I want to extrude it symmetrically so that it stays centered on the axes. And let's see, it is a thickness of 32. Okay, so that looks pretty good. Now the top has an arch, so I'll show you how to do that. So we're going to do a sketch, but I'm going to put it on the plane, the YZ plane there, and I want to go slice graphics so that I'm actually on the plane where my sketch is. And I'll do a circle. And let's see, my circle has a radius of 35. So I started drawing it. I'll right click, where's he at? Oh, radius. There we go. Radius of 35. Okay, so let's project geometry for the y-axis. Do a coincident constraint to center the circle on that. And then also, oh, can I do it? Let's see. Coincident there to there. Yeah. Okay, sometimes you have to project the geometry to get that to line up. And so now let's trim. Let's split it. Okay. Oh, it's one. Oh, it trimmed all the way around. So let me go back. Undo. Project geometry and choose that surface. Now I can trim. There we go. And now I should be able to extrude I'm going to go symmetrical through all, cut. And now my faces that I want is each of those slivers. Okay, that's cool. All right, now then, hole. I like using the hole command, but it has changed in our new version here. Let's see. Okay, so the hole is diameter 13, so it's a hole straight through. Diameter 13. Can I? It gets kind of wonky trying to make this thing. I really don't like the new hole command, the way that it works. A lot of times you have to actually put a point in. Okay, so now we got to dimension it. So, and it is 46 from the bottom. And it should be lined up on the center, so let's project that. Okay, so that made it work. And you could have, sketching it seems to be easier, but the new hole command has changed, so we do what we can. Okay, now chamfer on the front edge, it's a 45-degree chamfer that's 10 millimeters on each side. So we can go with our first option. Change that to 10. Pick that corner and that corner. And then there are two 11 millimeter holes on the top surface. I will try this again. Let's go ahead and change it to 11. It's just, it just seems kind of weird that you have to. It just seems backwards, you know what I mean? And that should be 13 from the back. and 13 from the right edge. Now, one way to work around that is you could do a sketch and place the points and dimension them, and then do the whole command and place the holes on the point. That would work. So there is the finished product of the rod support. If you have any questions, send us an email. Come see us on WebEx or come to the lab, okay?